Hi, I'm Adam. Welcome back to Godot GameDev. In this episode, we'll implement ranged attacks and projectiles in the game. So with the game open, if I buy a couple Robins and maybe one or two Bjorns as well, put them on the battlefield, buy some XP and start a battle, you'll see that we no longer just have debug messages, but we have arrows flying around at the enemies. So we can have full-on AutoBattler style battles now. Let's see if we can defeat the enemies. And you'll see we have a couple of screen flying arrows, but we have those covered and we have no extra arrows in the remote scene tree, so no arrows or projectiles going to infinity. Pretty cool. So let's see how we can do this. Let's start with the architecture first. So in this episode, to introduce the ranged combat, we have to create a new component called Projectile. And this is what a projectile will look like inside the scene tree. You'll see the projectile component itself is a node 2D and is the root node of this scene tree. And we make it as flexible as possible so we can create projectiles and make them behave in any way we want them to, with a few restrictions that they have to implement. So in terms of the battle unit, what we'll do is we'll instantiate a new attack component next to the melee attack, and we'll call this a ranged attack. And it will behave similarly to the melee attack. The only difference is that when it uses a scene spawner, and that scene spawner will spawn some kind of a projectile for ranged attacks. So we have to create this sort of hierarchy. So we introduce a new attack component, instantiate a new scene spawner under it, and for ranged attacks, we'll assign a projectile kind of scene to the scene spawner. So we'll do that from code. And to make these changes, we also have to change the BattleUnit's script. So we have a reference to the ranged attack component we introduce. And when we have that reference, we can make the final change, which is changing the auto-attacking state. Because if you remember, we only have placeholder code from the last episode for ranged attacks. But now we know that every battle unit has a ranged attack component attached to it. So we can spawn the attacks from the ranged one instead of the melee one like we do for melee units. Of course, this assumes that the configuration of the unit stats resource is correct. So for melee units, a melee attack spawn scene will be configured, and for ranged units, there will be a projectile pack scene attached to the unit stats resource. So let's see how we can do this. So I have the project open here, and this episode will be a bit of a breather after the previous one, as we'll only add ranged combat to the game, and this will be significantly easier since we have all the foundations laid out for us already. But before we jump into that, if you remember in the last episode I said that there's something that we might refactor in the next one. And that's exactly what we're going to do. So let's go to the script tab, press Ctrl-Alt-O, and search for the auto-attacking state script, AutoAttackState.gd. And if we scroll down, you'll see that when we call this attack method, where we spawn a hitbox for melee units, what we do is we set the collision layer and the collision mask for that hitbox, for that attacking hitbox, based on the unit stats resources theme property. So we did all those calculations. But I said that we do this in multiple places in the project already, so if we were to ever change those layers, then we have a bunch of magic numbers sitting around in the code of the game, which is always kind of a code smell, telling us that there's something wrong with this code. So why don't we fix that? It's a minor refactor and it's pretty easy to do. The way I usually go about stuff like this is when I identify it, I initiate a search, right? So let's find all the places where we do this, and then decide how we can and where we can extract that functionality. So in this case, we are looking for places where we set the collision layer or the collision mask for area 2Ds in code. So to search for both of those, what we can do is we can select collision underscore, press Ctrl-Shift-F, search for collision underscore, we can match the case just in case we wanted to, and we can click on find. And with the search results, we see that we have the detect range where we do this, but it's slightly different there. We have the auto attack state, which we have open here. And we have the battle unit, where we also do this, both for the battle unit itself and the herd box of the battle unit as well, right? Now comes the question, where do we put this new functionality? Where is the place where we can make all those 2s and 1s go away? What's the common pattern here? If you think about it, all of these search results have stats.theme, right? So what is stats.theme? In this case, it's actorUnit.stats.team. So the actor unit is a battle unit, right? And in the battle unit class, we do have our stats property, which is, if we press and hold Control and click on it, it's a unit stats resource, right? So if we press and hold Control and click on the unit stats class, you'll see this is probably the longest script in the whole project right now. This is the resource that describes one unit in the game. And of course, we reference this because this holds the information of which team that current unit belongs to. And setting those layers and masks depends on the team of that unit, right? So probably if we always need a unit stats resource to set this from code, this would be the place to do it, right? It makes a lot of sense, I think. So we can collapse the search results for now. We'll get back to that in a second, but if we collapse it, we'll see better the list of methods we have inside this script. And we have a bunch of getter methods. So what we can do is we can click on get time between attacks and do this very easy fix. So what we'll do is we'll introduce two new getter methods. We'll call one get team collision layer and get team collision mask. And both of those return an integer because we use integers to set the number for collision layers and masks. And we do the same calculations we do in the code right now. So if we go back to the search results and scroll a bit down, you'll see that we have stats.team plus 1 and 2 minus stats.team. Stats.team plus 1, 2 minus stats.team is the same thing everywhere except for the collision layer in the detect range, because that's on a different layer for both the player and the enemy, but this doesn't really matter since it also has this team plus 1. So we can kind of extract that functionality out, and all these places can get rid of those magic numbers. And if we were, for whatever reason, want to change those layers and masks in the future we only have to do it here. And in the detect range if that changes, but that's a different story. Okay, so let's make the changes one by one. We can save the unit stats itself with Control S. Click on the detect range script, and this is really handy because it opens up the script right where we want it to. And instead of stats.team plus 1, we can just do 4 times stats.get team collision layer. And instead of 2 minus stats.team, we can also just do stats.get team collision mask. You see, the 4 remains here, but that's the only place because, again, the detect range uses 2 separate layers, so it doesn't pick up projectiles and attack smears and other hitboxes in the game. So we can save this script with Control S. We can hit refresh on the search, and you'll see that inside detect range we have more results because we have this collision underscore on both sides of the assignment, but we no longer see the 2 and the 1, right? So we're done with this. We have these 2 new matches from the unit stats, but these are just the new setter functions we introduced. And if we scroll down, we have the AutoAttackState and the battle unit still waiting for the refactor. So let's click on the AutoAttackState now. And instead of actorUnit.stats.team plus 1, we can do actorUnit.stats.get team collision layer and get team collision mask. And also let's not forget to delete the 2 minus, right? Because this whole method returns an integer. We don't need the plus 1, but we don't need the leading 2 minus either. Save this with Control S, hit refresh. Now we have more results again because of the same thing, but no 2 or 1, right? And go to battle unit. We have the set stats method, and this can become stats.get team collision layer. This is the same thing because this is for the hurt box and it has the plus 1, so get team collision layer. And this one, let's not forget to delete the leading 2 minus, so stats.get team collision mask. Right? If we save this with Control S, hit refresh, and we have no sight of using that same magic number in the code anyway. Awesome, so that's the minor refactor we wanted to do. Just to make sure that it works, we can run the game. Buy a couple units, drag them inside the game, buy some XP, click on this. Okay, so we do still have the same functionality, no error messages or anything like that. Awesome. With that out of the way, we can actually move on to implementing those new ranged attacks. And we can do multiple things next, but the thing I want to get out of the way is actually adding stuff to the battle unit and making all the changes there so we won't forget it later down the line. So let's go back to 2D view. And I have my battle unit open here, but if you don't, just press Ctrl-Shift-O and search for battleunit.tscn. And here, if we collapse some of these just so we can see the scene tree a bit better, we have our melee attack here, our flip sprite, and a bunch of components we already used. And we can add the ranged attack and all those nodes we need. So let's select the battle unit, the root node, click on the plus sign or press Ctrl-A and search for attack. Let's add an attack node, let's drag it up under melee attack, double click on it and rename it to ranged attack. Press Ctrl-A again or click on the plus sign and add the scene spawner component. Let's double click and rename this to projectile spawner. And for this, we would have to set this export variable to determine which scene this spawner spawns, but it will be very similar to what we did with the melee attack. So if we expand this and click on it, if you remember, we left that at empty because we do this from code, right? The kind of projectile that the battle unit spawns really depends on the type of unit it is, right? So it will need to be set in the unit stats resource itself, and then we assign it via code. So we can leave this for the projectile spawner empty for now, but for the ranged attack, we have all the dependencies we need. So for the parent, we can assign the battle unit. For the anchor, we can use the attack anchor. For the spawn point, we can use the attack marker. And for the spawner, we can use the projectile spawner. Now let's make this a bit wider so you see everything. If you remember, I told you that for the attack anchor and marker nodes, you could just provide this on a per unit basis if you want to match the art of the unit better, or the sprites. In this case, what you can also do is you can have a different anchor and marker for ranged and melee attacks if you wanted to. And you can also do that on a per unit basis. So this would essentially mean that for all units in the game, you can set unique markers for both melee or ranged attacks. But since they usually do only one of those, one would be enough per unit. Here I just wanted to go with a simple solution. The projectiles will spawn from here compared to the unit. It's perfectly fine. It will look fine, trust me. But if you don't like it, you can always just go for a different implementation if it works better for your game. Right, so that's all there is to it from the scene editor side. Let's save this with Ctrl-S and let's click on the script icon next to the battle unit. And if we scroll all the way up, what we also need to do is to provide an already variable reference to that ranged attack component. So let's drag this over, press and hold Ctrl and release the left mouse button. And just to keep the sort of same order I have here, I just hold Alt and use the up arrow to move this up under the melee attack. And now we have that reference. So what we can also do is we can scroll down where we have this line of code where we set the melee attacks scene spawners scene that we use to spawn based on the unit stats resource when we change it to a new one. And to make this work, so we can get the prep out of the way, we essentially want to do the same thing for the ranged attack, but use the ranged attack property of the stats resource. Because if we press and hold Ctrl and click on it, we define a melee attack, which has a default one if you don't want to provide it over and over again, the same one for melee units. But for ranged attacks, we have a different export variable, and that's the one, that's the pack scene, that's the one we reference here. Right? So we added this line of code, and if we scroll up, we added that already variable reference. Let's save this with Ctrl-S, and if we go back to 2D view, we added these two nodes and set up the export variables for the attack one. And that's about it for the battle unit preparation. We can move on to creating the new projectile component next. In the file system doc, let's expand our components folder, right click on it, create a new script, and call it projectile.gd. Click on create, scroll down and double click on it to open it up in the script editor. And I wanted to show you a pretty cool technique here. So the way I want projectiles to work in this game is that all projectiles should have a speed that they travel with. And since we want to use the projectiles to hit something, right? What we want to do is somehow enforce that all the projectiles have a hitbox child, and to make sure that we don't have to delete projectiles manually when they go out of the screen, we can use a visible on-screen notifier 2D node for this. So what that built-in node does is if that object goes out of the screen, it emits a signal. So we know that it's not visible on the screen anymore. And this is good because if we have an orphan arrow that we shoot towards a target, but that target dies or moves in the meantime, then the arrow will fly to infinity, right? Out from the screen. And we don't want to create that memory leak that the projectile keeps traveling to infinity. So what we can do is just use that node and connect to that signal when the projectile goes out of the screen. So basically, we want to provide the flexibility to create and structure projectiles however you want them to, but we want to enforce that they both have at least one hitbox and one visible on-screen notifier to the child. We can do this in Godot, and if you think about it, we already do this in Godot with built-in nodes. Let me give you the example. So if you go back to 2D view for a sec, if I select the detect range, right, this one, and delete that collision shape 2D, what happens is we get this warning sign that consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. Otherwise, an area 2D is useless on its own, right? And if I undo this by re-adding that collision shape 2D, the warning message disappears. So that's a good way to do this because if for whatever reason non-programmers open up the project and use it, they have this warning message, and it's useful to devs as well, so you don't forget. And we want to use a similar approach here. We want to provide that warning message when you don't have either a hitbox or a visible on-screen notifier 2D node added. So the first thing we do is we add the @tool notation above the class name and the extends class name. What this does is it makes sure that the script runs not only when you run the game, but in the editor as well. And that's really useful here because we want to display the warning sign in the editor, right? Then we provide the custom class name and call it projectile. And for the speed, it's pretty simple. We just provide an export variable which will determine the speed of that projectile. Now we have 4 member variables. 3 of those will have custom setter functions and 1 won't. And that's the direction where the projectile will fly towards. And then we have a hitbox, a visibility notifier, and the target. And the target is vector 2, which gives the global position where the projectile wants to fly towards, basically. Now what we do inside the ready callback is we connect the 2 signals. We have one signal on every node called child entered tree, and we have one called child exiting tree. The reason why we connect to those signals is so we can use the hitbox and the visible on-screen notifier 2D. Basically, we want to grab a reference to them, but we can use the already notation here because we can be sure that those children nodes are already added, right? Think about the bare area 2D. So we have the warning message exactly because there's no child that entered the tree under that area 2D, which is a collision shape. So we have to connect to that child enter tree and exiting tree signals. We'll get back to that in a second. The reason why we see so many error messages is because we are yet to implement any of these. Now for the projectile itself, traveling is not that difficult. We have the physics process function, and if we don't have a valid target, we can return immediately because the projectile cannot fly towards a non-existent target. But if we do have a valid target, we update the global position based on the direction we want to travel towards, and just multiply that with the speed and the delta, so it moves frame rate independently. And the next one is a pretty big one, so this is a bit of a magic function we can use in Godot, and it's a built-in method. We can override a virtual method called getConfigurationWarnings. And what this does is it returns a pegged string array, so basically an array of strings, where you can have multiple warning messages. And you see what we do is we check if we don't have a hitbox, if our hitbox member variable is null, or our visibility notifier member variable is null, then we can return this error message that projectiles need to have hitbox and visible on-screen notifier to the children nodes. Now, if that's not true, it means that we have both of those, so we return an empty array, which is the equivalent of not having a warning message. If I press and hold Control and click on this, here's the doc page. The elements in the array returned from this method are displayed as warnings in the scene doc if the script that overrides it is a tool script. That's why we need that as tool. Returning an empty array produces no warnings. And you see an example here as well. And the example and the docs also says that you need to call update configuration warnings when the warnings need to be updated for this node. And that's exactly why we have setter functions for the hitbox and the visibility notifier variables, because we don't want to do anything besides setting the values to the new ones, but we do need to have setter functions because when we set the value, we have to update the configuration warnings, right? If it's null, then we will display this warning, but if it's not null, then we might return an empty array. And we have to do the same for the visibility notifier variable as well. And now if we scroll up, we have one setter function yet to do and those two callback methods for when a child enters the scene tree for this projectile. And the setter function for the target, it's pretty simple as well. We set the member variable to the new global position, but setting the target also means that we can set the direction member variable as well. And this will be the projectile's global position. And using the vector2.direction2 method, which if we press and hold Control and click on it, returns the normalized vector pointing from this vector to 2. This is the equivalent of using p-a.normalized. And now that I read the documentation, I realize that this .normalized call is completely superfluous because this method does return a normalized vector. And next, we have those two callback methods for the child entered tree and the child exited tree signals. Both of those signals pass in the node that entered or exited the tree as a parameter. So what do we need to do here to, one, provide the updated warning based on what kind of child entered the exited tree, while also making sure that when we actually run the game and not just the editor, we can have access to the hitbox and the visibility notifier nodes inside the game. It's pretty straightforward actually. We need to provide a check which does two things. First, we want to check if the child that entered the tree is a hitbox, and we don't have a hitbox set yet. So the hitbox member variable is null. Because if that's the case, it means that there was no hitbox registered yet, but now we have one. And if that's the case, we assign that hitbox member variable, that child, as a reference, and we can connect the hitbox's hit signal to the queue_free method. And this is needed for the game logic itself. So when the projectile hits an enemy, we want to delete the projectile, right? And we kind of do the same thing for the visible on-screen notifier 2D node. The only difference is that it has this screen exited signal, but we do want to do the same thing in this case as well, right? When the projectile exits the screen, we no longer care. It won't ever hit anything else, so we can just delete the whole projectile. And the reason why this solves our configuration warning update as well is because this line of code and this line of code will both trigger the setter functions, and the setter functions have this update configuration warnings calls, right? So this both handles the gameplay logic for this component and the editor logic, so we have this warning displayed. Now we just need to do the opposite, so when a child node is exiting the scene tree. And we can provide a safety check here that if not engine.isEditor hint. And what this does is this will be true when we are running the script inside the editor and not the game. So if a child is exiting the tree and we are inside the game, we don't care. Why? Well, because if a child is exiting the tree and we are inside the game, it usually means that the projectile itself is being deleted, and in the game it doesn't really matter that much. Because then when we delete the projectile, we're just done with everything, right? But if we are inside the editor and the child is exiting a tree, that we deleted a child node under this projectile. And this does matter, because if we deleted our registered hitbox, then first of all, we can disconnect from the signal we connected to it here. And second of all, we want to trigger that setter function again by explicitly setting the hitbox to null, because this will trigger the warning message, right? If we scroll up, we set the hitbox to the value, which is null in this case, and we update the configuration warnings. So now this part of the statement will be true, and we get the warning message back that buddy, you messed up something because there's no hitbox anymore. And we want to do the same thing for the visibility notifier member variable as well. Disconnect the signal and then set it to null. So we don't have that lingering connection either. So with this setup, I know it's a bit more verbose doing this editor side of things because this component will be much, much easier if we just assume that we have those two child nodes at all times. But I just wanted to show you this cool technique that you can use as a dev. So if we save this script with Control S and go back to 2D view, we can actually start creating a projectile just to test this out. So if we click on the plus sign to create a new scene, click on other node as a root node, we can now search for projectile. And you'll see that we have this warning message here that projectiles need to have hitbox and visible on-screen notifier 2D children nodes. Cool. So what happens if I click on the plus sign, add a hitbox, click on the projectile again, click on the plus sign, and add a visible on-screen notifier 2D. You'll see that the warning message disappears. So far so good, right? But if we take a look at the output window, we do have an error message saying that projectile.gd line 50 invalid access to property a key hit on a base object of type hitbox. Okay, we'll get back to that in a second. But let's see if it works if we delete these nodes, because right now we have the warning message disappear. If I delete that visible on-screen notifier 2D, delete it, the warning message comes back, add it back again, the warning message disappears. Let's also clear the console for now. Now if I delete the hitbox and press OK, something's a bit messed up because we have an error message now on line 62 and the warning message goes away. And that's a problem because now we should have the warning message because we only have one of the two we need. So something's a bit messed up and we have line 50 and 62. So let's go back to the script tab. And so line 50 is where we set the hitbox when the child enters the tree and connect to that hit signal. So this is where we had the error message, and also line 62 when we disconnect from the same signal. And it says that invalid access to property key hit on a base object of type hitbox. Now this is a super weird bug, considering that if I press and hold Control and click on the hitbox, we have this signal declared here, right? So how am I not able to access this when it's clearly defined in the class and it's a hitbox class? So do you have any idea why this works with the visible on-screen notifier 2D but not with the hitbox? Well, one of the things we have here is that this whole hitbox is tested. We know that it works and we used it in a game in a couple of times. And the main problem we have is that this script attached only really runs and has access to all these things inside the game. Because if you take a look at the projectile script and the hitbox script, one of the differences between the two is that this cogwheel is blue here, which is an indicator that this is a tool script that runs inside the editor. So I found when creating this component, if we make sure that the hitbox like this is also a script that can be interpreted inside the editor. So if we add tool at the top of this and save the script with Control S, this seems like a small change, right? But now if we go back to 2D view, close this unsafe project so we make sure that we create a new one and we have everything reloaded. Our root node will be a projectile node. We have the warning message. Click on the plus sign, add a hitbox. We have the warning message. Add a visible on-screen notifier 2D. The warning message disappears. Now if we select the hitbox and delete it, we have the warning message back, right? Now we do have this invalid access error still, but at least we get the warning message back. And if we add a new hitbox to this, it disappears. And we don't have an error message anymore. Again, if we delete it, no error message. The warning comes back. Re-edit, we have this warning message, but this is only because of the area 2D. If we delete the visible on-screen notifier, we get the warning message back. So now everything works as expected and no error messages when the project is open. Looks good, right? Well, it kind of works and it looks fine, but we do have one slight little problem with this. And namely that in the projectiles script, we connect to these two signals in the ready. Can you guess why this might be problematic? Well, if you remember in Godot, what's the order of the nodes being ready in the scene tree? the way it works with projectiles, if we have two children, for sure, a hitbox and a visibility notifier, those as child nodes will be ready first, and then finally, when all of its children are ready, that's when the parent node will be ready, right? And the thing is, by the time we connect to those two signals in the game, those variables won't be set, right? Because when this node is ready, its children are already entered the tree because they are ready. Hopefully that makes sense, right? So basically, we have the opposite order for ready and enter tree. So for ready, the parent's ready will only be emitted when all of its children are already ready. But for enter tree, it's the opposite way around. So if we press F1 and search for enter_tree, it says that this is called when the node enters the scene tree, for example, upon instantiating scene changing or after calling add child in a script. If the node has children, its enter tree callback will be called first and then that of the children. Now what this means is inside the editor everything looks fine, but only when we create a new scene. Let me show you. So if we go back to 2D view and let's start creating Robin's projectile, right? So we'll create a projectile, call it Robin arrow, press Ctrl A or click the plus sign. Let's add a hitbox, click on it again and add a visible on-screen notifier 2D. The warning message disappears, so let's save this actually for now. So if we press Ctrl S, go to scenes, the same way I did for effects, I'll create one underscore folder for the projectiles. I have the same logic I told you in the last episode. Let's save Robin arrow. And if we close that scene for now, let's clear the output messages. And if we press Ctrl Shift O and open up Robin arrow, that's the issue we have with ready. So now we have both the hitbox and the visible on-screen notifier 2D. It's the way we saved it, right? But we do have the warning message showing to us. And this is because when we instantiate that scene inside the editor, this will be ready, then this will be ready, and only then the Robin arrow, the projectile node, will be ready, and we only connect to the child entered tree signal when the root node is ready. So when you create a new projectile scene, this is not a problem because yes, that one node when you add it will be ready. You connect to the signal, and after you add the new nodes, then you will do this setting business. But when you reload one or instantiate one dynamically inside the game, this breaks things because we connect to this signal too late. Those two children nodes will have already entered the tree by the time this parent projectile is ready. So this is one of the rare cases where we cannot really use ready here. And instead we can override another virtual method called enterTree. And this tiny little change again, if we pull up the docs, it says that this will be called on the parent first and then on the children. So we can be sure that this will be called before the child nodes emit their tree entered signal, right? So with this slight little change here, if we save it with Ctrl S, go back to 2D view, close that Robin arrow scene for now, press Ctrl Shift O, reopen Robin arrow, you see, the warning message disappears. But it still works. If I delete that visible on-screen notifier, it comes back. If I save this as is, close the Robin arrow scene, reopen it, I do have the warning message, and it's a correct one because I don't have the visible on-screen notifier, but if I re-edit, it comes back like this, save it, close it, reopen it one more time, and see, no warning message. It's a bit more advanced, but hopefully you learned something useful with this one. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Now with that interesting experiment out of the way, let's actually create this Robin arrow scene, right? So let's select the root node first and set the speed. I'll use 300 for the reference project, but you can experiment with this value later on. Let's also zoom in a bit to see what's going on better. And now we have all the required child nodes we need to have, but we can go ham with all the other parts of this projectile implementation on a needed basis. What we definitely need to have when we press Ctrl A is a sprite, right? Because we want to display some image. Let's drag this up. For the texture, click on quick load, and we have this arrow.png. which, as you can see, has multiple frames for animation, and it has 2, 4, 6, 8 different frames. So let's go to animation and set the H frames property to 8. This pinkish rectangle is displayed by the visible on-screen notifier 2D. If we click on this, you can set the rectangle it uses for collision checking. Basically, if it's outside the screen or not. The default value is perfectly fine for this. Now for the hitbox, we can add the collision shape. So press Ctrl A and search for collision shape 2D. We'll use a rectangle shape 2D for this one, but it can be actually much smaller than this on the Y. So click on the rectangle shape 2D and set the Y to something like 10. I think works pretty well with this arrow. And just to make it a bit more interesting, let's select the root node, Robin arrow one more time, and click on the plus sign or press Ctrl A, and let's add an animation player node as well. For the hitbox, we don't really have to set the damage or the collision layers in the editor. You can do this if you wanted to, but since we already took care of this from code for the melee attacks, we'll do the same for the ranged ones. So if you want to use the same arrow for enemy units, you don't have to create a duplicate of this scene because we handle this dynamically. It's also true for the damage as well. So let's just create the animation. And this will be a pretty simple one. Click on animation, new, and I'll just call this flying. This can be like 0.9 seconds long. We can zoom in with control and mouse wheel scrolling like so. Set the snap to 0.1 and turn off snapping to integer FPSs. And turn on snapping to timeline cursor, so when we drag it around, it goes with these increments. And I don't really want to overcomplicate this animation. I just use a sprite 2D and keyframe that frame property, which will toggle between the 8 H frames. Click on the key next to it, create the reset track. And what you need to do is you just need to keep pressing that keyframe button, and it will automatically move those 0.1 seconds for you. And if we scroll back this animation and play it, it looks like this. If we zoom out a bit, maybe turn off the collision shapes for now. Yeah, so it looks like the arrow is rotating as it's flying around. I think it looks cool. And to make our lives even simpler, so we don't have to do any coding for this, what we can also do is we can turn on autoplay on load. So this animation will automatically play when we instantiate it in the game. And that's all we really need from this scene. So we can save this Robin arrow scene with Ctrl S. But let's not forget that we need to assign this to Robin as the unit, right? So let's search in the file system doc for robin.trs. But I want to show you another trick you can use. So if you don't want to find this file system doc to use filtering for one file, this filtering is super useful on its own, but if you use something like that, TRES, it's good for like filtering through. But what I dislike about it for things like this, like robin.trs, is that when you double click on it and you have your resource open, it's easy to forget to delete this filtering, as it won't be automatically deleted when you double click on a file or something like that. So an alternative to this is to just go back to the scene tree like you usually use it. And if you press Ctrl P, it's basically the same thing. So you can search for files in your file system doc, but it won't leave that filter in. So now if I search for Robin, you'll see that I have all the files with fuzzy search added. So if I press enter on robin.trs, it will open it in the inspector, but the filtering remains empty. So that's another trick you can use. Again, it's Ctrl P. So now we have Robin open, and you'll see that the ranged attack is empty. So what we can do is we can quick load Robin arrow.tscn. So now we have that ranged attack, this arrow assigned to that unit stats resource. And while we're at it, we can also add an auto attack sound as well. So let's add a new audio stream randomizer. Click on it, set the playback mode to random because we'll only have one sound really. So it's impossible to avoid repeats. I'll use the random pitch of 125 for this, and also a random volume offset of 0.2, so it's not always the same loudness. And we only have one stream, so we can add a stream and quick load robin1.wave. And now our unit stats resource for Robin is ready to go. The one final thing that's left to do is to hook this up in the auto attacking state, but I realized that we haven't really tested the projectile yet in isolation, so we can just test it in isolation to see if it works. Save the robinarrow.tres for now. And to test it, one thing we can do is we can go into move mode by pressing W and just drag it to the center of the screen, like that. And if we go to the projectiles script, just add a very simple override of the input virtual method. And if we press Q, the test1 action, then we just set it to the right, and also auto delete itself when it goes out of the screen. So save this, go back to 2D view, go back to selection mode by pressing Q and run the scene with clicking on this button or pressing F6. So when we run this, the animation plays, but I haven't pressed Q yet. Let's go to the remote scene tree. We have Robin arrow here. If I press Q, arrow flies out, but as soon as it reaches the end of the screen, it deletes itself. Right? So far, so good. What we haven't tested is if it hits an opposing enemy team, that the hitbox's hit signal will be emitted and it deletes itself, but I think that's fair to test in battle, and it's easier than setting up a whole test scene just for that, when we are only a few lines of code away from actually doing that. So let's just reset the transform. So select the root node, Robin arrow, go to transform and click on this arrow to reset the position. Go to the script tab and get rid of this testing code. Save the script with Control S. And we have one final hookup to do. And that final thing is super simple. So let's just press Ctrl+O and search for AutoAttackState.gd. And what we need to do here is replace this, right? Because whenever Robin should shoot an arrow, we just print this debug message. And instead we can do something very similar to what we did with the melee part of this conditional statement here. What we'll do is we grab the actor units, ranged attack component, and attack at the target's global position, and we cast the returned node to a projectile, so we have auto completion. Again, this assumes, just like we did with the hitbox for melee attacks, this assumes that the scene that we assign to a unit stats resource for ranged units is a projectile. Then what we can do is we can set the target to the target's global position, so it starts flying towards the target, and set up everything else. We set the hitbox's collision layer and mask, the damage. For these values, we just grab them from the stats resource because we have those getter functions. And finally, we connect to the hitbox's hit signal to that on attack hit, which, if you remember, handles mana generation and so on. Just to make sure, if we wanted to, we can connect this as a one-shot method, so it doesn't get called multiple times, just like we did with the animation finished. I don't know if that's possible, because whenever we emit the hit signal on the hitbox, we also queue free the projectile, so it will be deleted. It doesn't really matter, I think. If we ever see a bug with ranged projectiles, we might want to revisit it, but I don't think it matters that much in this case. And that's all we really need to do. So in theory, we should have a range attack system implemented in the game as well. So let's just save this with Control S and test it, shall we? Go back to 2D view, play the game. Let's buy a couple Robins, and maybe with 4 tier 1 units, we should be able to win now. But let's just use one Bjorn so we can see the arrows better. Buy some XP and start a battle to see what's happening. And what's happening is that we have an error message in the set stats resource. And it says that invalid assignment of property or key scene with value type of pegged scene on a base object of type nil. Now that's strange. Maybe we forgot to set up something. If we take a look at the filter stack variables here, our ranged attack component is a valid object because it has an ID. If I click on it, nothing happens because I'm in maximize mode, but if I exit this, you'll see the problem here. We have the parent, the anchor, and the spawn point, but for the spawner, this is null for whatever reason. Let's just check our battle unit scene because I remember setting this, but we might have a different bug here. So let's go back to the battle unit scene. Go back to 2D view, and for the ranged attack, maybe I forgot to set this spawner because it's empty, but I remember setting this, but might just be a silly mistake on my side. So let's click on assign and select the projectile spawner because that's the one we want to use for the ranged attack. So the ranged attack should have the projectile spawner and the melee attack should have the melee attack spawner, right? So now this should work. So press Ctrl S and play the game again. Let's buy those robins again and the Björn. Now I'm expecting 0 error messages, but we'll see. Let's start the battle. And those arrows are flying around and damaging the enemies. Awesome, we have no error messages anywhere. And maybe we'll still lose the battle with tier 1 units by the looks of it. Awesome. So if you want to see the battle in a bit of a more visible way, we can turn off the FSM debug label for the units. Press Ctrl-Shift-O and open the arena scene and turn off the unit navigation debug. We save everything with Ctrl-S and run the game again. We might have a clearer view of the battle and we can buy maybe 2 Robins and 2 Björns now to see if we can win against those ogres. And it already kind of starts to feel like a full-on AutoBattler game, and you can see those arrows kind of flying off the screen sometimes, but we don't have extra arrows spawning in because of the visible on-screen notifier 2D nodes, right? No error messages, we won the battle. So the next logical step will be implementing the spellcasting system in the next episode. I'll see you there. Bye-bye.